Check, check. Hello, math students. We're looking at the section called Geometric Means. It's 2.3 Go. Directions say for each geometric sequence below, find the missing term in the sequence. So I came up with a method to find that those missing terms in the sequence. So I'll show you the long way, my thoughts on the method I created. Well, first things first, geometric sequences are derived by multiplying by a common ratio. In other words, there's a number that you continually multiply by to get from one term to the next. So what we know is this. It's geometric, so the number 2 was multiplied by some value. This first term was multiplied by some number. We'll call that number, why not call it b? It was multiplied by some number called b to get to this next value. And then that value is multiplied by that same number b to get to the next value. And that value is multiplied by b to get to the next value. And then that value is multiplied by b to get to 162. So what I know now is this, that 2 times b times b times b times b equals 162. So I'm going to write that down. Simplifying that, I get 2b to the 4th equals 162. Now, if you know what b is, if you can guess and check 2 times some value of b raised to the 4th power equals 162, then you have the common ratio, the multiplier, and use that to find the next term. Now, in algebra, though, we learned that we could solve for variables by isolating the variable. So if I was to divide by 2, b would equal 81. And so here, b to the 4th equals 81. And without knowing anything about roots, you could take 81 and break it up into its prime factors. What that looks like is this. Let me just take 81 over here, pick a different color, and let's use a prime factor tree. 9 times 9, 3 times 3, 3 times 3. So you can see that 81 is 3 to the 4th power. 3 times 3 times 3 times 3. And so, moving in this direction, so you can see now that b would equal 3. Since 3 to the 4th power equals 81, right? So now we know this is going to be multiplied by 3. So we end up with 2 times 3 is 6. 6 times 3 is 18. 18 times 3, 24, 54. Yeah. And there you have it. So we found the values of the geometric sequence. Now, so see that method that I used and try to use it yourself. It's kind of drawn out. It's a little long. You can guess and check to try to figure it out too as well. But the other technique was this idea that you could make this process quicker by seeing that this is always the method used. And so here's how I found the geometric multiplier. All right, here's how I found the geometric multiplier, the common ratio. I took this pattern. It is the second term that's given divided by the first term. Then you take the nth root of that, where n is the second term number minus the first term number. So in this situation, our second term was 162, and our first term was 2. And then our second term number was 5, and our first term number was 1. So let's plug those in and see what we get. geometric multiplier would have been 5 minus 1. Oops. 162 over 2. And that's what's going on there. Let's take a look. That's a square root symbol. We can see that 5 is the second term number. 1 is the first term number, 5 minus 1. By the way, you'll see that that's 4. And didn't we move 4 times by multiplying by b 4 times to get to 162? So that's that value here. And then of course 162 divided by 2, that was this step up in here. Take a good look. See that? And that was this here. So using that process, we end up with fourth root of 81. Now what does that mean? Well, the fourth root means what number do you multiply by 4 times to get 81? And that number here, check it out, that number was 3. 3 times 3 times 3 times 3, 81. So the fourth root of 81 equals 3. Since 3 times 3 times 3 times 3 is 81. And that was your multiplier, which is what we found. So I hope that helps. Like I always say, study hard, learn a lot, and we will see you soon. Bye-bye.